All right, guys, so to get started, so we're finishing up this here. This is the last section of the note sheets for the factoring test because there's really not much else we can do. Now, the note sheet, so this here, we're finishing up factoring 3, the last part of the note sheets, and we're going to do this one here. Now, I said yesterday that we were done with sum and difference of perfect cubes, but I wanted to look at this one here mainly because this is the first one out of all the ones we've done where the variable only shows up once and it's in the second spot. Not any different, just something to look at so that we can say, so that y'all can have seen it and know how to work with it. Yes. Yeah, so it's on that first file. Now, with any of these here, we do look for a greatest common factor first. Well, between 125 and x cubed, there's not one. So we can kind of look at the cubed roots. Now, part of the reason we take the cubed root is, one, to make sure that they are both perfect cubes, and two, so that we know our first and second term, our a and b. Now, out of these two here, the cubed root of x cubed is kind of the easiest one to do because it's just x. Whenever the cubed root, the root and the power, exponent, are the same, they simplify out. Now, for us, we can take the cubed root of 125, and we see that it is 5. Questions on this so far? Now, our next part, we can set it up. So we'd have our first set of parentheses with 3 spots, and our second set of parentheses with 5. And when we put the signs in, the signs are going to be the same, opposite, always end on a positive note. So since we have a difference of perfect cubes, so to be the same, we would have minus. Opposite would be plus. Always end on a positive note is going to be plus. So we have minus, plus, plus. Now the next part that we plug in is the first term, and here our first term is 5. And a lot of the others, it was x for a variable, but here it's 5. So our first spot's going to have 5. And the bigger one will have 5 squared. 5 to the first, and the last one we could write in 5 to the 0, but that's just going to become 1, which we multiply with the second term. So we don't have to put it in. Now this time our second term is x. So here we have x. With 5 squared, we'd have x to the 0, which would simplify to 1. So we don't have to write it in. The middle term will have x to the first, and the last one will have x squared. At this point here, we can simplify it. Now for the first set of parentheses here, we'll have it as 5 minus x. Now we could try to rearrange it and put the x first, but I would leave it as this here, because otherwise we'll have negative x plus 5. It looks better. I like it better as 5 minus x. Inside the bigger parentheses, we have 5 squared, which is 25, plus 5 times x is 5x. Plus x squared. Yes, it's just in the opposite order. Now, I mean, we could rewrite it as negative x plus 5 times x squared plus 5x plus 25. That is another way to write it. We don't have to flip both. We could leave it as x minus 5, or 5 minus x times x squared plus 5x plus 25. I would write it as either one of the two that I boxed. I personally don't like having negative x plus 5 inside the parentheses. It's a little weird. But 5 minus x works just as well. Any questions on this here? Note sheet? Need a note sheet? You're welcome. I end up always having one extra. I can get you another one. Any questions on these here before we start looking at grouping, factoring by grouping? Now, when we look at factoring by grouping, is what it's called mathematically, what we refer to it. I like calling it greatest common factor twice, is really what we're looking at. And what we'll do with this is group them together to try to factor it. Because looking at these four terms, it's kind of hard to see how it would factor. But if we group it and take the first two and the last two together and look at them individually, we want to factor something out of each one so that we have something in common after it. So if we look at 2p cubed and 5p squared, well, 2 and 5 do not have a greatest common factor. But p cubed and p squared do, then it would be p squared. Because I can pull two of those variables out of each one. We won't pull it out of the entire thing, just out of the first two here. Because if I factor p squared out of p cubed, we still have the 2, but now it is 2p. Plus, we still have the 5 because I'm not factoring out a number. But if I factor p squared out of p squared, it factors out completely. So what I'm left with is p squared times 2p plus 5. Bless you. Plus, now when we look at 6p and 15, is there a greatest common factor between those two? Yes, and it is 3. And if I factor a 3 out of 6p, 6 divided by 3 is, and we still have the p. Plus, 15 divided by 3 is, and this is what we want to have happen. We want to have what's left over be the exact same. Because what we can do now is greatest common factor again, but this time what I'm factoring out of both of them is the 2p plus 5. We're very used to it being a single term, but it doesn't have to be. It can be an expression. So we can factor the 2p plus 5 out of both. We can divide it out of both. Now, when we factor it out of the first term, parentheses, when we divide it out of the first term here, all that's left is p squared. Plus, when we divide it out of the second term, we're left with 3. So these here are our factors. Because we factored out, we divide this out of both of them, which leaves us with the p squared plus 3, and we have the other part out front. Questions on this here? It's weird that it works this way, but it is nice. Now this works with an even number of terms. So 4 works out fine. 6 works out fine. Because we can do it as 2, 2, and 2, or 3 and 3. We can split it up. But with 5, it doesn't work. Because we really need an even amount with each group for us to be able to factor it out. Now we look at this here, 3n cubed minus 4n squared plus 9n minus 12. Now, realistically, how we group it up really doesn't matter. Because we could do the 3n cubed and 12. We could do the negative 4n squared and 9n. We can group it however we want. Because I always go normally doing the first two and last two, because it really doesn't matter how we do it. But to do it in any other way, I have to rewrite it so that I have them next to each other and then try to factor it out. Because here, we can pick one, and I would always pick one that you can find a greatest common factor easily. So the 9 and 12 have a greatest common factor of what? And if we factor it out, 9 divided by 3 is, and we still have the n, minus 12 divided by 3 is 4. Any questions on this so far? Now for the other one, inside the parentheses, I need this to be 3n minus 4. Because for us to be able to factor out, do our second step, our second set of greatest common factor, we need those parentheses to be the same. So I know if one of them is 3n minus 4, the other one has to be 3n minus 4. Now what can I do to 3n squared and negative 4n squared to get to 3n minus 4? What can I factor out? And if I do factor n squared out of both, we do get that set of parentheses. So really, finding the easier one to factor out, I can use it, once I factor it out, to get the other one to be the same. So sometimes we find the one that's easier and then manipulate the other one to get it to be the same, to get it to match, so that we do have this 3n minus 4, so that we can factor it out, which leaves us with n squared plus 13. Now, I know that this one's already done, because 3n minus 4, what is the degree of 3n minus 4? What's the degree of this one here? First, because the biggest exponent attached to the variables is 1, yes? So that's as simplified as it gets, linear. What's the degree of the second one? 2, it's second, yes? So there is a chance that it could factor, because that's one way to check and make sure are they completely done, is looking, are the degrees 1? Well, first one, yes. Second one, no. N squared plus 3. Well, it's not a difference of perfect squares, most likely, and again, it doesn't factor, so we're done. But any of them, if they have a degree greater than 1, you need to check and make sure, does it factor or is it fully simplified? Here it is. If it had worked out to be, say, n squared minus 4, that is a difference of perfect squares. We can take it a step further. Any questions on this here? Do we need to see another example of one of these here? Let's look at this one here. This one here will be the last one we look at. I think that's the last one that we actually have, yes? So looking at this here, we're trying to see greatest common factors between these, yes? I'm going to pull up the graphing calculator, because there's different ways to find greatest common factor. One of them is dividing both numbers by a certain number and seeing does it work out evenly. The graphing calculator, if you do hit math and we go over to number, if you notice all the way down here, number 9, GCD, greatest common denominator, greatest common factor, we can hit this here. And our first two numbers are 224 and 4, comma, So the common number between these two is 56. And we can check that. We can say 224 divided by 56 is 4. And this is helpful, especially on the ACT. They will sometimes ask what is the greatest common denominator or greatest common factor between the given sets of numbers. And we can do that. Now, this here only does 2 at a time. So you can do 2 of them and then pick the other one and put it in place of it and see what it is. So here, if we had a third number, well, we know that 56 is the greatest common denominator between these two. I would replace 56 with the other one and see what we get. So what that told us is between these two here, we do have a greatest common factor of 56. Is there anything else in common with the first two? Hey, because the other variable is z and c, those aren't the same, so we'll leave those there. Now, as we already saw, 224 divided by 56 is 4. A factors out completely, so we're left with z plus 56 divided by 56 is 1. A factors out completely, so we're left with c. So this is helpful because we know over here, for us to use factoring by grouping, or greatest common factor twice, the other set of parentheses needs to be 4z plus c. Yes. To where it doesn't work out? It's possible, but that means if that's the case, it's either going to require more manipulation or it just doesn't work that way. So that's what we want to have happen. So we want the 84 to become 4, and we need the 21 to become 1, yes? So let's see what 84 divided by 21 is. So we know we're going to have to factor out 21. Well, the first one has yz, second one has yc, so we also have to factor out the y, yes? Because that's the next step. What else do we notice about these two terms? Are they positive or negative? They're both negative, yes? And we need them to become both. So what else do we factor out? Now we can factor out the 4z plus c, which leaves us with 56a minus 21y. Math. 56. So this here, if we were saying to factor it, it is factored. If they ask for it to be factored completely, they would technically mark it wrong, or at least partially wrong. Because as I was looking at this here, these two have a greatest common factor of 7. Because 7 times 8 is 56, 7 times 3 is 21. So what we could do is factor the 7 out. Still leaves us the 4z plus c, but this here becomes 8a minus 3y. I'll take either one, because if we factor the 7 out of those two, we get 8a minus 3y. So that would be factored completely. There's nothing else we can do to it. This first one is factored. This second one is factored completely. Because 56 and 21 have a common factor of 7. So we can factor it out of both. So instead of putting it in the middle, we put it out front. So really all we did was the second one here is 7 times 8a minus 21y. So we just pulled it out of that one. And this whole thing is being multiplied by? Yep. So we factored out a 1. Now, because it was kind of hard to see, it actually worked out that at the beginning we could have factored the 7 out and then gone through our steps. But it works out that all 4 of these here are divisible by 7. So we could have factored that out originally. But either way works. Questions on this here? And that is it.